Hello, this is Taha Ahmed and I am here presenting packet capture. So let's get started. The first part is to browse Google and capture those packets. We can see that there's a long list of packets. This is an example. The source IP is my host. This is the destination, which is Google server IP. The protocol is TCP. Let's get inside of the packet. We can see the layer 1 information and then encapsulation type is Ethernet. The layer 2 information tells us that this is Ethernet type 2. This is the protocol in the type field. This is IPv4 information, the source IP address and the destination IP address. This is protocol and the protocol port number 6 TCP. This is TCP header and we can see that the destination port is 443, which is HTTPS. This is the reply back from the Google server and the destination is my host. This is the same layer 1 information, layer 2 information, the IPv4 addresses, and we can see that we are getting this information on port 443. This is the SSL, secure socket layer. This is for securing layer 4 information. So now let's go to the second part of the presentation. This is the topology we have created. We have few loopback interfaces, and for packet capturing we have enabled packet capturing on central router interface F0/0 and central router F0/1. So let's go to the packet capturing. This is the ARP packet, and because it's a layer 2 protocol, we cannot see the IPv4 header here. This is the layer 1 information, layer 2 Ethernet type 2. Because it's an ARP packet, so we can see the type is ARP, and this is the ARP header. ARP is actually when the machine has IP address but is actually looking for the MAC address. ARP is also useful when the machine is acquiring for IP conflicts, right? So it's a broadcast message, so it's FFF in hex. The next is RARP, reverse ARP. The same layer 2 and layer 1 information we can see, and again there is no IPv4 header because it's a layer 2 packet, layer 2 frame, sorry. This is the reverse address resolution protocol header, and we can see that there are no IP address but MAC addresses. RARP is actually when the machine has MAC address but no IP address. Alright, this is the OSPF hello packet. When we have configured OSPF, the first part is to send hello packets to your neighbors. We can see the layer 1 information, layer 2, layer 3, and we can see actually that the destination is a multicast address. OSPF send routing messages, routing information through multicast addresses. This is the OSPF header. We can see in IPv4 header that the protocol is OSPF IGP, Interior Gateway Protocol, and the port is 89. OSPF does not use TCP or UDP but uses its own protocol. This is the OSPF hello packet, and we can see the hello interval, which is 10 seconds. The dead interval is actually the 4 times of the hello interval. This is OSPF LSA, link state acknowledgement. LS acknowledgement is actually when the router is acknowledging the LSA packet from other router. So we can see there are several OSPF headers acknowledging for receiving different LSA headers, LSA information. This is a ping ICMP. This is actually a ping request, you can see, and its reply is in another ping, which is 1323. This is the ICMP payload, and you can see that Wireshark has arranged this information for us. We can see that this is the request packet, right? And Wireshark is telling us that the response from the packet is from frame 1323. So we can see the response is here. See, so this is the reply. This is the reply, or you can say response. The request frame the Wireshark is telling us is 1316. Right. The last thing is is fragmented. When we send big packets on the router interface for ping, the router cannot send all it at once, so it actually fragment it actually break it down, and this process is called fragmentation. So you can see that at IPv4 we can see that this is written here, reassemble IPv4 in frame 1323. So it means that packets are coming in pieces called in fragments, you can say, and then they are reassembled in the device and at the interface. We can see the data, and there's a long string of data. That's all for today. Thank you very much.